Hi, my name is Bob Hardaway. I'm a solution architect with Kyligence. And today I'm going to provide a brief intro and demo of our Kyligence cloud product. The topic today is achieving sub-second response times for Azure Analytics. So Kyligence Extreme Analytics. Kyligence has evolved and accelerated the process of delivering analytic data to your end users through a number of key technologies and concepts. First of all, we support all major data platforms, whether you have a traditional data warehouse, whether you're embracing big data within a data lake, whether you're now streaming as well as doing batch and historical analytics. And all the while, people tend to be moving to the cloud environment. So Kyligence can help you accelerate and derive more value out of data wherever it exists within your enterprise. A primary concept for Kyligence is this idea of precomputation, and in our case, intelligent, using actual historical analysis, query patterns, data definitions to improve the performance and make sure that that sub-second response continues over time. We also disrupt the way traditional warehouses are thought in terms of providing horizontal scaling capabilities. And I'll show you how we do that through our cuboid and heavily indexed solution. And our query routing, we're going to be able to direct queries to the appropriate tier within the infrastructure to make sure that that user experience stays consistent. Kyligence also has dramatically improved the ability to support large communities of users. Kyligence customers often have thousands of analysts, business users, marketing individuals who are all wanting to access that critical analytic data. In traditional solutions, challenges around running queries while cubes are built or while other loading is done cause tremendous problems. And adding even a few additional users to an environment often creates a lot of latency. And then finally, we know that the BI environment is a combination of many tools and capabilities. And Kyligence provides support natively for all of those tools and BI dashboards. This is the high-level architecture of the Kyligence Analytic Cloud. What you see here is Kyligence orchestrating and working seamlessly between your source data systems on the left, like I mentioned earlier, warehouses, streaming data via tools like Kafka, and also data lakes, and any of the major cloud providers. Today, we will focus on Azure, but Kyligence works just as seamlessly with any of the other clouds, Alibaba, AWS, Google Cloud Platform, for example. Under the hood of Kyligence, you have that precomputation layer. This is where Kyligence is going to predict and allow the modeler to determine which aggregations of data are most relevant to the business solution. That, along with indexing, will be built at what we call build time. In the modeling layer, we have a very user-friendly semantic and also semantic layer capability that allowed the modelers to translate from the IT-centric definitions, DDLs, schema definitions, etc., translate that into more user-friendly and understandable information for the business users to consume. And so working the way to the left is that description of pretty much any and all of the consumers of this analytic data, starting with those BI tools, Excel, which we'll show today, but also other downstream users, data scientists who are requiring data sets to feed their machine learning and predictive modeling. Also, SaaS applications, CRM, running or able to consume the Kyligence output as a service, literally data as a service. So the paths I'm going to show in the demo, we're going to use Snowflake. Snowflake is kind of a very popular cloud data warehousing technology today. We're going to use that as a source. Within Kyligence, we're going to emphasize our MDX capability. MDX is a multidimensional language that allows you, again, to sort of simplify and produce more consumable outputs for your downstream users. And on the back end, we'll show Excel, the de facto, sort of pivot table and analysis tool for most every enterprise. Give you a little more detail on under the hood how Kyligence can ensure this sub-second latency and performance. One of the key ways is through this intelligent query routing engine. Kyligence is going to take the queries, the dashboard interactions or the queries from any SQL tool, and it's going to determine how best to satisfy and provide answers to that information within Kyligence Enterprise. So you see on the left that the cubes that I showed earlier and the table indices that Kyligence pre-computes, the goal is for them to be able to satisfy 95, 98, or even 99% of the queries through that pre-computation layer. That's where sub-second response is very predictable and will continue no matter how large those assets grow. But there's also this compromise of some queries, the ones that are least important to your users, so try to keep this down around 2 to 3%. Kyligence will push those queries down directly to the source. So you'll see today that with Snowflake, if there are edge cases or detail queries that the user wants to execute, those will be pushed directly down to Snowflake. All the while, that intelligent AI augmentation system is going to monitor performance. And if more queries begin to be pushed down, the modeler has ample opportunity to improve the performance. Make sure that the 95 to 98% of queries are always coming back in sub-second. All right, so let me drive into the demo here. I am going to start with the end in mind. So I'm going to take you directly into Microsoft Excel. I'm going to use the data connection capabilities native to Excel. And our MDX product is going to expose an interface that allows any Excel user to connect just like they would against the Microsoft Analytics services. So I provide an endpoint. This is the URL for the Kyligence MDX server that I'm talking to today. I'm authenticated either through Windows Active Directory or direct. In this case, I'm just using a username and password. And Kyligence or Excel is going to go connect to that MDX instance and allow me to peruse data sets. In the MDX world, a data set is your fundamental grouping of dimensions and facts. And so I'm going to select this TPC data set. TPC is a very well-known benchmarking capability within the analytics and OLAP world. And so we'll use that for demonstration here today. And so as soon as I make that connection, I can easily bring that data resident into my Excel world, and Kyligence and the MDX module immediately help me build out a pivot table capability. So you see here that the objects that are exposed through MDX are somewhat abstract. I'm not having to understand any of the joining conditions or even the detailed dimensional attributes that might exist within Snowflake or within my cube environment. I'm simply able to begin using these entities that Kyligence has created to begin building my pivot table. I selected a date hierarchy. Kyligence provides a very powerful capability to create hierarchies in your data. In this case, the obvious date relationships or year, quarter, month. But I can aggregate and create other types of hierarchies like regional, country, state, city. Any natural hierarchical organization I can model very easily here. So what I'll do is pull in the revenue information, which is my metric that has been built. And I'll also drop YTD, year to date. I'll show you when we go back into Kyligence how this was created. But that's a KPI, a metric that is calculated within the infrastructure. The real value here, besides being able to develop a pivot table very quickly, is that I can ensure that that type of calculation, whether it's year to date, year over year, any of those key performance indicators, I can calculate those once within Kyligence and ensure that all of my BI tools and consumers are using that accurate, consistent piece of information. A big challenge for any enterprise analytics or enterprise organization is that as you roll out more BI tools, more dashboards, and you provide the ability to generate statistical analysis on the fly, the problem is that errors will obviously and very quickly creep in. So I call this define once and then consume many, but it provides a huge degree of consistency for the enterprise. The last thing I'll do is add a filter. The data that we're looking at is revenue, sales performance, but it has parts or manufacturers of those parts built in. And so within just a few clicks, I can immediately start to drill into my hierarchical information. So you see I can drill down 1994 through Q2. I can get daily information on revenue. And then I've also got year to date. So Kyligence is calculating daily, monthly, quarterly, what the net, what the overall metric is. And the last thing I can easily do is drill into any one of filters that are relevant. Here you see I've got 5 different manufacturers, and simply by making that selection, I can update and filter that data to be just manufacturer number 3. So that really is the power on the back-end BI tool scenario. Without Kyligence, your Excel users are often sharing workbooks or asking IT for access to information, data marts, etc. Again, a lot of siloing and the potential for inconsistency. And then performance-wise, we'll drill back into Kyligence, and you'll see the query times for a lot of the steps that I just took. But again, we're working with a couple 100 million rows here today, and you saw performance that allowed the user to build this, pivot table literally within, 15 or 20 seconds. All right, so now I'll take off the hat of that BI analyst, and I'll put on the hat of the Kyligence data modeler. I'm going to log into Kyligence Enterprise or Kyligence Cloud here, our enterprise version. And what you see is that I am running on Azure here. All of the resources supporting Kyligence are deployed directly into Azure. This cloud capability allows me to manage monitor, scale, and retire all of those resources very, very easily. So another key ability for Kyligence is to provide maybe companies that are just moving to the cloud, that are a little perhaps nervous or not sure how to monetize or keep costs down. Kyligence is excellent at providing that framework to allow you to directly move to the cloud, maintain costs, but also drive that user consumption. So the workspace that I'm looking at here is a series or a set of resources deployed on Azure. And I'm going to drill into my project. One thing Kyligence does is provide a data catalog. So I can, again, ensure consistency, and I can dramatically reduce the amount of ETL, data movement, creation of marts or views for different users. What Kyligence provides here is a single data catalog that can be all or most of my Snowflake data. I can combine that with other sources, and I can provide a single shareable catalog. Once I drill into this project level, now everything I build here is just for the particular data modeler. So many modelers, you may have dozens of different analytic projects. They can all share that single data catalog, but also have their own workspace, their own project to begin building and modeling. So what you're seeing here is a summary of the data that Kyligence has, metadata that Kyligence has collected and is aware of. So what you're seeing is being directly queried from the Snowflake source. So the first step for Kyligence to build out that data catalog is to actually go in and select and do the parsing of the metadata to build or bring into the Kyligence catalog. Once that step is complete, the key to Kyligence is building a model. So what I'm able to do is maybe create a new model. And I'm provided with a very intuitive, user-friendly canvas to begin that process. You can see here that Kyligence is giving me some guided navigation to help the user understand what steps are required or what steps to take next. And it's really very intuitive. I'm going to pick my line item table, which looks to me to be the fact table. So I'll identify it as a fact table. I'm going to go ahead and select customer to join in on. And if you remember in Excel, we had that part. We had manufacturer. So I'm going to bring in that dimension as well. Having dropped those onto the canvas, added them to my model, the next step is very simple as well. I'm just going to take the part key from the line item, and I'm going to marry that with my part dimension. Kyligence supports inner and left join out of the box, but I can also create more complex joins. If there are complex or combination keys, I can support that here. I can add the dimensions to the model. The dimensional attributes here are those filters that I'm interested in applying to the data. So if you recall, manufacturer, brand, type, and size, those would probably be of interest to that Excel user, so I can add those. And the final step is to identify measures. So I can select extended price here and drop it in as a measure. What Kyligence allows me to do here is enhance that semantic capability. So I can translate from L extended price to price or something more informative. And I can impart that translation here within the Kyligence layer. What I'm going to do now is just show you a model that has already been constructed. And so this is based on that same TPC data set. You can see the fully populated model. One thing I'll touch on is aggregate groups. The way Kyligence is able to ensure this performance is through some tuning parameters known collectively as an aggregate group. What this allows the modeler to do is to preclude against sort of unlimited growth of the information within Kyligence. As the number of dimensions increases, as the depth of the fact data goes from 2 years to 4 years, et cetera, you want to maintain that performance. And these aggregate groups are the key to Kyligence being able to do that. So basically what this is going to do is limit the explosion, the growth of that model by allowing the modeler to define sort of the most important paths for that analysis. And again, the beauty of Kyligence is that this is not a one-time only get it right or else type process, which it often becomes in some of the traditional warehousing approaches. Making changes to, you know, a SSAS model or an Oracle data warehouse can become not only very difficult but cost prohibitive. Kyligence is designed to support that type of change just sort of natively. That's, you know, an aspect of data and analytics today is that, you know, two things will be constant. Your data will grow. You'll have more data tomorrow. And you'll also have the need or the desire to add more dimensional attributes and more sources to that model. So that capability is really built into Kyligence. Let me touch on the jobs. Kyligence is running on Azure at this point. And what Kyligence has created is 2 clusters. One of those clusters is called the build cluster. That cluster takes care of loading data from the source, from Snowflake in this case, and building the cuboids, building the highly indexed and performant information within Kyligence. The other cluster is the query cluster. So there's a very clear separation between the two. As I alluded to earlier, a lot of traditional OLAP systems are forced to literally have 2 different operational modes. During the night, when users are asleep, the loading occurs, right? And those jobs often take, you know, 2 to 10 to longer hours to complete. During the day, loading ceases because you don't want users to suffer from that degradation, and query users take over. With Kyligence, because of this delineation between the 2 types of Spark clusters, that boundary is blurred completely. Loading can take place and querying can take place, and they have their own dedicated resource pools. So just to kind of finish here within the modeling capability, Kyligence provides a built-in query tool. It's pretty basic. It's not meant to be as full-featured as your SQL analysis or other workbench products. But what it does provide is the ability to test and optimize and tune your model very effectively. So this query that I ran here is a little bit complicated, but at a high level, it was part of that pivot table build that we saw earlier, being able to aggregate over ship year, ship quarter, ship month, et cetera. And then the summation is by the actual revenue data itself. And you can see that Kyligence shows me this query ran in you know, about 1/3 of a second. I can now export this query to CSV if I'm so inclined, but I'm able to tune and optimize the performance of Kyligence right here within the tool itself. So last part of the demo is I've shown you Excel as the consumption And now I've shown you how that AI augmented engine is created and how it performs. And so what I'll finish with is the MDX capabilities of Kyligence to define multidimensional concepts and data sets and really just improve that Excel behavior and user experience dramatically. So what the MDX module allows me to do is to create a data set. I'm creating that based on the models that you saw earlier that I built within Kyligence. And what I can do here is enhance that model in a couple of critical ways. One, you notice that you see year to date here. So year to date is a calculation, an expression defined in the MDX query language and added to the Kyligence infrastructure. What I could also do is change the name of YTD to be year to date. I can provide a description here so that the end user has a better understanding of what that calculated measure entails. And I can also do some of that semantic translation. I can take, very, technical definitions from Snowflake or from another database and translate those into, much more user-friendly information. Basically, by finishing and publishing this data set, I now allow any of those Excel, Power BI, or Tableau users to connect to Kyligence and begin to use that data set information directly in their analytic processes. So that completes the demo today of the Kyligence analytic platform, achieving sub-second response times for Azure Analytics. Again, my name is Bob Hardaway, Solution Architect for Kyligence. Thanks for your attention, and we'll see you soon.